Hi guys, welcome back to our channel. So today I'm going to solve some questions that were there in GATE DA sample paper which was provided by ISC. So they did not provide the answer key or the solutions to this paper, but when they introduced the GATE DA paper, they actually released a sample paper to give you an idea how the paper will be. So these questions are on linear algebra from the same paper, so we'll be solving them today. So let's start. So this is the first question that I'm going to solve today. The question is saying that a matrix H has been given to you and it's known that one of the eigenvalues is 5. Now they are asking about the other eigenvalue. So you can solve this question very easily if you know how to find the eigenvalues given a matrix. And this is a 2 cross 2 matrix. So it's very fairly simple to find the eigenvalues. Okay. So we should know how to find the eigenvalues. If you know this, you will be able to solve this very easily. Okay, so let's see how to solve this. I'll just copy this matrix to my next slide. And here we go. Okay. So how do we find the eigenvalues is that we try to construct the characteristic polynomial and we set it to 0 and then we find the roots, right? So we'll do characteristic polynomial. So how do you construct the characteristic polynomial, or how do you find the eigenvalues? Is you take the determinant of this particular matrix. This is 9 minus lambda, assuming lambda is the eigenvalue, and 6 minus lambda. So this is a 2 cross 2 matrix, so we'll find 2 eigenvalues and we have to set this determinant to be 0. Okay, so when I do this, the determinant of a 2 cross 2 matrix is very easy. We can do it like this: 6 minus lambda minus 2 into minus 2 is equals to 0, correct? Now we'll do 9 cross 6 is 54, 9 minus 9 lambda minus 6 lambda minus, this is minus, so this will become plus, so this is 4, right? Now we'll do 54 minus 4 is 50. I have missed lambda square somewhere. Yes, I have missed lambda square. So let me just erase this. Minus lambda, and here I missed one term, which is lambda square is equals to 0. Then this is 54 minus 4 is 50. So this is lambda square minus 9 lambda minus 6 lambda is minus 15 lambda. So I'll just add them up here, and then I have minus or plus 50 is equals to 0. Now you have to just find the roots of this. So the roots of this will be lambda square. So I'll just do it here. Lambda square minus 5 lambda minus 10 lambda plus 50 is equals to 0. Lambda, I'll take the lambda common, minus 10 I'll take common from here, is equals to 0. Lambda minus 10 and lambda minus 5, right, equals to 0. So which means lambda is equals to 10 or lambda is equals to 5, right? So these are the two eigenvalues. Now let's look at the options that we had. So the options we had were 12, 10, 8 and 6. So one of the eigenvalues given to us is 5. So the remaining eigenvalue is 10, right? So the answer is 10. Fine. So this is a very easy question that was given in the sample paper, and the answer is 10. So this is one of the approaches that I wanted to discuss. Now this is taking a lot of time to do the computation. There is another approach which will take you just seconds to solve it. Okay. And it's related to the property called trace. So trace of a matrix H is actually equal to sum of its diagonal elements, which is indeed equal to the sum of the eigenvalues. Right? So because they have given us the matrix, it's very easy for us to compute these things, right? So we'll just take this matrix here and we'll see. So trace of the matrix is equals to sum of its diagonal elements. It means 9 plus 6 is actually equals to 5 plus whatever other eigenvalue that we are trying to find. So this is 15 is equals to 5 plus x, and x is equals to 10, right? So, and this is what we were getting as the answer from the first approach as well. So this is the easier and the faster approach to do it. So for that you should know this particular property, that the trace of a matrix is actually equal to sum of its diagonal elements and sum of its eigenvalues. Now let's do one more question from the same sample paper. So they have given us that the two eigenvalues of 3 cross 3 matrices are I plus 1 and 2. Now we have to find the determinant of the matrix X. Okay. So for here you need two concepts. So the first concept is that complex eigenvalues always occur in complex conjugates. Complex eigenvalues occur in pairs of complex conjugates. What I mean with this is, I'll just come to this, conjugates. So what I mean is that if my one value is eigenvalue is I, the other will be minus I. Okay, and if it's 2 minus I, the other will be 2 plus I, and so on. Okay, so though they have given us two eigenvalues, we actually know the third one. So the third eigenvalue will be the complex conjugate of I plus 1. Third eigenvalue is 1 minus I. Okay, so we know three eigenvalues. Now we know three eigenvalues. This is a 3 cross 3 matrix. So there is one more property that will help us solve this question. So the other property is that the determinant of matrix, what is the matrix given? X, right? Determinant of X will be equal to lambda 1 into lambda 2 into lambda 3. Fine. So determinant of X, we know 3 lambda values. So this is a property that you should know, that you can compute the determinant of the matrix using the eigenvalues also, right? So we have 3 eigenvalues. It's a 3 cross 3 matrix. So I can just multiply the 3 eigenvalues that I have and I can get the determinant. Okay, so the eigenvalues are 1 plus I into 2 into 1 minus I. So this we found from the property that the eigenvalues will occur in pairs of complex conjugates. Now we can just multiply this. So this is I 1 square minus I square into 2, and I square is nothing but 1. I square is equals to minus I square is equals to 1. Positive 1, right? Minus I whole square is equals to positive 1. So sorry, so 1 square minus I square into 2. 1 square minus I square is equals to minus 1. I square is minus 1. So this is minus 1 into minus 1 into 2, right? So this is 2 into 2. So the answer is 4. Okay. So the answer for this particular question is 4, right? So it's fairly simple question if you know these two properties. Now also let's look at the third question.